Alright, section D, solving radical equations and check for extraneous solutions. So this just means solve for x and then check it. So I'm going to make a little section off to the side for checking the extraneous solutions. So starting with number 18, we would first subtract 5 from both sides. So reverse order of operations. We're left with 3, x plus 1 to the 1/5 equals 6. Okay, so what we do not do is distribute 3. That is exactly what we do not do. What we're going to do is divide by 3. So we can cancel it out. And we'll end up with x plus 1 to the 1/5 equals 6 divided by 3, which is 2. Next, we're getting rid of that 1/5 exponent. So we don't really need to write this as a radical. If you want to, that's fine. What we can do is just multiply by the reciprocal. So 1/5, the reciprocal is 5 over 1, or just 5. So remember, we multiply by the reciprocal, so when you multiply straight across, this will end up being 5 over 5, which is 1, and it will cancel. And if I raise the right side to the 5th power, I have to raise the left side. Or no, the left side. If I raise the left side of 5th power, I have to raise the right side. So this will be x plus 1, 2 to the 5th is 32, and then subtract 1. So we end up with x equals 31. Okay, now we're going to check for extraneous solutions. So that means we just plug this back in for x. So this is 3, 31 plus 1 to the 1/5 plus 5 equals 11. So we're trying to see, is this going to add up to be 11 on the left? I'm going to rewrite this as a radical now. So whatever's in the denominator goes in your index. 31 plus 1 is 32. Plus 5 equals 11. Well, if 2 to the 5th is 32, then the 5th root of 32 is going to be 2. So 3 times 2 plus 5, and 6 plus 5 indeed is 11. Good. So this is true. Next one. So we don't have anything adding on the outside of this radical or multiplying in the front, so we can first just get rid of the radical by raising it to the 3rd power. So raising it to the 3rd power cancels out the radical. I'm left with 5x plus 3 equals 27. Now I'm going to subtract 3 on both sides, and this will be 5x equals 24. And then we divide by 5 on both sides. Oh no, not a fraction. Yes, a fraction is our answer. Now we're going to check over to the right. Is it extraneous or not? I don't know. Let's plug it in. This will be the 3rd root of 5 times 24 over 5 plus 3 equals 3. So is this going to add up to be 3? So here, 5, if I go to multiply this is like 5 over 1. And you can multiply straight across. I know, though, that since I have 5 in the numerator and 5 in the denominator, they will cancel out. So if you're unsure of that, we can try it just multiplying straight across. Turning on would be good. 5 times 24, so multiplying straight across, is 120, divided by this 1 times 5, or just 5. So divided by 5 is 24. So that's why these just cancel out. So this will be the 3rd root of 24 plus 3, and the 3rd root of 27 equals 3. That is true. Yes. Okay. Next, number 20. Here we have the square root of 4x. So what I'm going to do first is square both sides. So square it. I want you to get this confused with what we're doing here. So I'm just going to erase it. Okay, so squaring both sides. Okay, we square both sides because when you have just the radical, there's technically a little 2 there, and that cancels out our radical. So our 4x is free. And x minus 8 is, will we distribute the 2? No, you do not distribute 2. We write this out twice. X minus 8 times x minus 8. And we FOIL. So this will be x squared minus 16 plus 64. And, 16x, my bad. So minus 16x. So here we have x squared and x. So the only way we can solve this is by factoring. Yes, we need to factor. So to factor, we need it set equal to 0. So to set it equal to 0, I'm going to subtract 4. And so I have 0 equals x squared minus 20x plus 64. So if you remember factoring trinomials, which I hope you do, this would be, you start off with a times c. So a times c, 1, so a is 1, times c is 64. And we're trying to think of two factors that when multiplied equals 64, but when added equals 20. So I know some of us use this method, and I would put, I think you put the 64 on top, and then the negative 20 on the bottom. So two numbers. It might take you a few tries to try dividing 64 by different numbers, and you'll find that 4 times 16, so negative 4 times negative 16 equals positive 64, and when added equals negative 20. So this will rewrite as x squared minus 4x minus 16x plus 64. So we're replacing our middle value. Now we do the factoring by grouping. So looking at our first group, the GCF is x, and you divide x out of both terms to get x minus 4. GCF in the second group would be 16. I can divide 16 out of both of these. So do minus 16, and this will be x minus 4. So remember, our goal is for these two to be the same. So now I take what's on the outside, I write x minus 16, and what repeats I write once. Okay, so to finish solving, we set both of these equal to 0. So x minus 16 equal to 0, we'll have x equals 16. Set this equal to 0, we'll have x equals 4. Now we have to check it, as if this wasn't enough work. So here, I'm going to try plugging in 16. So I have the square root of 4 times 16. Will it equal 16 minus 8? So since I have two x's, I'm plugging in that x value of 16 twice. Okay, and then on this side, we'll have the square root of 4 times 4. Is it equal to 4 minus 8? So 4 times 16, 64. What square is 64? That is 8. 16 minus 8 is 8. So this one is true. This one, 4 times 4 is 16. Square root of 16 is 4. 4 minus 8 is negative 4. So these are not equal. So the one that will work is 16 and not 4. So that's why we have to check for those extraneous solutions. So on the back, not on the back, well, on the back of yours, on the front of mine, we have one more little guy up top. So number 21, finding your extraneous solutions. Okay, so for this one, I have the cubed root of 7x minus 9 plus 11. So first thing I need to do is subtract 11. So this will be the cubed root of 7x minus 9 equals 3. Okay, now we need to get rid of that radical. So to get rid of the radical, we raise both sides to the third power. and that cancels out the radical. I have 7x minus 9 equals 3 to the third is 27. Now I'm going to add 9 to both sides, and we have 7x is equal to 36. And then you divide by 7 on both sides, so x is equal to 36 over 7. Okay, now I'm going to plug that back in. Third root of 7 times 36 over 7, so I'm just plugging this back in for x, minus 9 plus 11 equals 14. Okay, so again, you can use your calculator to help you out. I think you should use your brains to help you out. 7 cancels, and then 36 minus 9, that's right, I use the calculator, 27. So I have the third root of 27 plus 11 equals 14. Third root of 27 is 3, and 3 plus 11 indeed equals 14. So that is true.